Hi guys, in this video we are going to fine-tune Llama 3 large language model. This video will be the continuation of fine-tuning of large language model. So in the last video we have talked about LoRA and QLoRA, which are the PEF techniques. So we have multiple options for fine-tuning the large language model. Llama Factory is one of them. Auto train is the another option. But in this video we are going to use Unsloth. We have taken this Jupyter notebook from Unsloth. So once you come to github.com Unsloth AI, you will get this Unsloth Repo, where if you come down here, you can see that fine-tune Llama 3 mistral Gemma 2 with 5x faster with 80% of less memory. And free notebooks are available here. They have the performance and memory usage column also, so you can go through it. Yes, I have taken this notebook for Llama 3. And I have made few changes. So going forward, I'm going to tell you like all the changes which I have done on this notebook. Begin the installation of all the needed packages. We'll start with Unsloth and then TRL, PEF, TextRate, and bits and bytes. We'll also install W&B, which is weights and biases. Those who don't know, weights and biases is basically a platform to build models faster, fine-tune LLMs, and develop Gen AI applications. So to start with, you can sign up, and the moment you'll sign up with Google or your email ID, you'll land up somewhere here. And this is basically how to start with. So pip install WNB and WNB login. So you have to provide your API key, and there's this very basic example for your understanding. We'll do the logging by passing the key. So we are going to import fast language model from Unsloth. We'll import the torch. We'll be providing max sequence length 2048 because the example which we are using, it doesn't have a long sequence. That's why we'll stick with 2048. But Llama 3 goes up to 8K. So if you are trying to fine tune something which is longer and your examples are longer, then you can basically give a longer max sequence length. Then dtype will keep it none so that auto detects will load in 4-bit true. And so Unsloth basically has all these 4-bit models. Few are from Mistral and few are from Llama and Gemma. So we are going to use Llama 3 8-bit, 8 billion BNB 4-bit. These are already quantized 4-bit, so we don't need to configure bits and bytes here in this example. Then we are loading the model and tokenizer by passing the model name and max sequence length. And for token, let's say for example, you have not used any of these 4-bit model, but you are using something from the Huggingface site. Then in that case, you have to provide the token also. So once the model and tokenizer gets loaded, we can basically pass the model and tokenizer in the generate language model output. So before we fine tune, we just wanted to test this model and see like what kind of output it is generating, so that we can have some kind of validation like, okay, how much this particular output has been changed and how much it has been improved. We are providing the Alpaca prompt and we are providing instructions, input and response. So let's quickly see the dataset on which we are going to fine tune it. So it's from llama alpaca clean. And if you see the structure, here also we have instructions, we have input and we have output. So what we'll do is we'll take one example like brainstorm possible solutions to reduce water pollution. The expected output is something like this, where we are getting answers in points: regulate industrial discharges, promote eco-friendly agriculture, and few more points are there. So let's see how it is generating the output for this particular instructions. So I'm passing the instruction, I'm passing the model, tokenizer, and Alpaca prompt. And once I get the generated output, I'm basically fetching the response out of it and showing it in the answer. So as you can see, the output is very weird and not at all optimized. So one possible solution to reduce water pollution is to use less water. Another solution is to use less water. Another solution is to use less water. So let's see if we can fix this problem with the fine tuning. In the data prep section, we are using the same Alpaca prompt which we have seen earlier. we are loading the dataset, Alpaca cleaned, as I've already shown here. So in this case, in this dataset, there are many examples where we don't have input, and assume it like the instruction is self-sufficient and has the input. That's why we don't have inputs in those examples. And we are loading the dataset, split equals to train, and then we are mapping it with the formatting prompts function. So what we are doing in formatting prompt function is basically we are extracting the instructions, input and output, and then we are basically doing a for loop and creating a bigger text. So this text is nothing but this whole text, and we are filling the instruction, input and response from the examples. So it's basically a looping over the whole 51.8K. Okay, so while training the model, we are going to use SFTTrainer, which is supervised fine-tuned trainer, and we are going to provide model, tokenizer, and dataset, and we are also providing the data type of the dataset. So here we can see that we have created text fields for the fine-tuning dataset. So we are going to provide text here. We are providing max sequence length, and in the training arguments part, we are going to provide max step equals to 60 because we do 60 steps to speed up things, but you can set it to number of training epochs equals to 1 for full run and turn off max step equals to none. Okay. Then we are using optimizer at Adam 8-bit, weight decay 1%, and learning rate scheduler type equals to linear, so that the learning rate varies. We're using learning rate scheduler equals to linear and output directory equals to outputs. And we're passing report to weight and bias so that we can see the training loss there. And let's start the training. So as you can see here, we can see the view project at Wandb, Ayansh, Roy, Huggingface. We can view the run at Wandb, Huggingface, run this. So here we can see all the important stats: learning rate, global steps, grad normalization, epochs, and training loss. We have a training loss here, but let's quickly jump into Wandb. So the training loss is also got reduced here. So whatever function which we had created, we will quickly copy this from here, right? And we'll paste it here. So we are going to ask the same question which we have asked previously before fine tuning, and the expectation is that this answer should be far better than the previous one, because in previous one we know that there was some repetition in the answers, and that answer was also not a comprehensive answer. So the question is brainstorm possible solutions to reduce water pollution, and we got the answer. So the answer is reduce the use of single-use plastics, implement water treatment facilities, and encourage the use of co-friendly cleaning products. So as you can see that the quality of answer has been drastically increased, and we have seen the sensible answers, sensible output from it. So definitely this fine tuning has worked, and now we can use it for our use cases. To save the model in your local, you can use model.save pretrain, tokenizer.save pretrain. To push it in the Hugging Face, you can use model.push to hub and tokenizer.push to hub. Now, there are different ways to load this fine-tuned model. You can make if equals to true, so that you can load this in your model. So this is the repetitive code. We have done this before also here. So we are basically loading it. You just have to provide the model and tokenizer, and you can load it. So this is again the same code, but yeah, you can use it for loading your fine-tuned model. And then you can also use Hugging Face auto model face peft causal LM. Though the Unsloth people have claimed that it is very slow, Unsloth inference is 2x faster. That's why they are basically expecting that you can use the Unsloth one rather than going to the autograph model for causal LM from Huggingface. Then you can also save it in float 16 for VLM, right? So these are all the ways to push it to Huggingface and pushing it to local. So both these, and then there's this GGUF data type which you can save. So those who don't have GPU, they want to run it on their local CPU capable devices, they can definitely go for GGUF, where you have the llama.cpp conversion. You convert it into different variants of it. You can convert it into 8-bit, 16-bit, and 4-bit. So yeah. So guys, that was it. I think we have covered most of the part from this particular Jupyter notebook, and I hope you have learned something and you have understood something. I hope you're going to try this thing in your local. And if you have any use cases where you are thinking like you are going to use the Llama 3 and you want to customize it on your own data set, or you want to refine the output of the model, right? You can do it something like this, what I have done here in this video. Yeah, that's all guys. Thank you very much. Bye. Have a nice day. Have a nice day.